All right, thank you, Patrick. Good morning, everyone. It's wonderful to join you at this 17th summit, which I have attended many times. I'm honored to speak with you about what the data is telling us, hopefully clearly and consistently, about climate trends in South Florida. So this work is rooted in collaboration with agencies, universities, counties, and federal partners. The goal is simple, basically to understand the evolving climate indicators that shape our region and use that knowledge to plan for the future, to be resilient, as we already heard today. Let me see if I can move to the next slide. So let's start at the global scale. Big picture, all these arrows, up and down, they're consistent with they reflect the projected changes under future conditions. Across the globe, climate indicators show accelerating change. There's data behind every one of these arrows. I have some of that data there. And when you look at, starting with the warming, which is the primary driver of many other impacts, we see that in the instrumental record from 2015 to 2025, we observed the 11th warmest years globally in the last 10 or 11 years. And this year is projected to be the second or third warmest. And going down to the ocean heat, we know that it absorbs over 90% of the excess heat energy from the atmosphere, and it reached the highest level of heat content in 2024. We know that the ocean warming has far-reaching consequences, degradation of marine ecosystems, intensification of tropical storms, and accelerate the sea ice loss in the polar regions, and together with melting ice from the land ice actually is driving the sea level up. We also know that sea level is accelerating. You see the numbers there, 2.1 millimeters per year from 1993 to about 2002. In the last 10 years or so, it has increased to 4.1 millimeters per year. So there's general consensus that it is accelerating. Glaciers are losing mass. You can see on the upper right corner there. And then basically, the polar ice sheets are losing mass. You see ice sheet extent is depleting about 12% per decade. Ice sheets are melting in Antarctica and Greenland, and that accounts for about 0.12 millimeters per year. So that's a significant source of future sea level rise. We also know that going to the atmosphere, the warmer atmosphere can hold more moisture. About, theory tells us 7% per degree Celsius of warming, and that could lead to enhancing rainfall intensity, particularly at shorter durations. We also know that on the lower right-hand side, the wildfire risks are increasing in severity and impacts, and in many regions driven by some of the climate changes we are seeing already. And if you look at the numbers there, California had $40 billion of wildfire losses, as you may have observed. More recently, there's a paper that shows that the continents are drying at an unprecedented accelerating pace. And about 2/3 of that loss is coming from groundwater depletion. So that's also a real concern. And flooding is increasing every year. You may have seen what happened in state of Washington recently. So these global trends form the backdrop for everything we observe locally. And they set the stage for South Florida's climate challenges. So looking at the national level, and basically We have information from the latest National Climate Assessment Report, which is the 5th National Climate Assessment Report. US is warming everywhere. You can see on the upper left-hand panel, particularly at night and in the northern latitudes. We see warm, increasing or frequent heat waves, which are longer lasting. And you see the upper right-hand corner, in terms of precipitation and extremes, you see increasing heavy downpours, particularly in the northeast, and increasing drought severity. Like in California, we have mega droughts occurring more frequently, and the drought severity is also increasing. See, again, with respect to tropical storms that we have to worry about, they form, when they form, they actually becoming stronger with higher rainfall in them. So that's also a concern for us. On the lower left-hand corner, as I mentioned, there are wildfires, longer fire seasons, area burn has increased, and also air quality is degrading far downstream of, downwind of the fire itself. One aspect that is important to us, the sea level rise, coastal change, and ocean condition. Sea levels are rising all around the coastline pretty much, and we see increased high tide flooding and marine heat waves. So these national patterns mirror what we experience here in South Florida: hotter temperatures, strong rainfall bursts, and higher sea levels. So COMPACT has been active in looking at these climate indicators for some time. Before I get into the details, I would like to acknowledge the team behind the production of this climate indicators report you see on the upper right-hand corner. The work reflects contributions from counties, cities, the University of Miami, FIU, South Florida Water Management District, and federal partners like LOMA, USGS, and many other independent consultants and collaborators. You see all the names in there. And I particularly want to thank Lawrence Evans, who actually organized these and got this produced for us. So this report exemplifies the co-production aspect of how the practitioners and researchers can work together to produce scientifically robust and practically useful indicators for all communities to use. So let's look at the South Florida. This is South Florida at a glance, summarizes the multiple climate stresses that we experience today. It's already experiencing rising air temperature, and ocean temperature, shifting rainfall patterns, more extreme precipitation, sea level rise, rapidly intensifying tropical storms. You see on the lower right-hand side, the tropical storms actually intensify more rapidly, like Hurricane Melissa we saw in Jamaica, and also increased flooding, saltwater intrusion, widespread impact on natural systems, creating what we call cascading and compounding disasters that we have to deal with that affect communities, infrastructure, and the economy. So these stresses interact in the way that will intensify flooding, strain aging infrastructure that we have, and affect ecosystems like Biscayne Bay. So as sea level rise, the groundwater elevation is also rising. Even a routine rainfall event could cause or challenge the urban flooding protections that we have. So that's another thing to keep in mind. Sorry. So let's move on to some of the indicators that we have produced. Let's start with the temperature data. This chart shows the minimum and maximum temperature during the hottest months of July to September. You see the upper curve showing the maximum and the minimum. The high temperatures are increasing about 0.3 degrees Fahrenheit per decade. But the nighttime warming temperature are even more pronounced, about 0.5 degrees per decade. And this is an important aspect. The nighttime temperature could have significant impact on human health. When nights stay hot, the body doesn't recover well from daytime heat stress, increasing risk for vulnerable populations and raising energy demand for cooling. So that nighttime warming is a real concern. Looking at the projections, the 50-year and 100-year temperature records has clearly, that the region is warming, especially at night. Sorry about that. So let's move down to sea surface temperature. Oceans around us tell a similar story. Sea surface temperature, you see the upper right-hand corner, the actual observations. You notice that 2023 was one of the highest, has been increasing. And in particular, in 2023, which has the highest in the period of record here, led to widespread coral bleaching in our region. And that's a real concern. And also, when you look at the projections indicate, you see the lower right-hand corner, the continued warming will have substantial ecological and economic consequences. You can see they're increasing significantly. So rising sea surface temperatures are disrupting ocean circulation and severely stressing Florida coral reefs, threatening ecosystems that are vital for tourism, fisheries, and coastal production. So that's why this matters to us. Think about heat index. You see on the upper left-hand corner, the increased temperature and humidity combine to shape the heat risk. This chart shows the number of hours during May to September heat season when the index reached 100 degrees or higher at major airport stations in our four-county region from 1996 to 2024. You can see a clear trend in there, and particularly in 2024. Now, actually, Miami-Dade County and Broward County are piloting updated heat thresholds based on local climate and health data. You can see those, the changed threshold values for heat advisories and excessive heat warnings. Looking ahead, the number of days with heat index above 100 could approach 20 days per year by 2100, more than half the calendar year. And that's what is expected from the modeling that we have received. So this will shape how we think about outdoor work, emergency response, and equitable access to cooling resources. In terms of precipitation, picture is a little bit more complex. We did not see a clear trend in the actual rainfall or seasonal totals, but we seem to see increased evidence of short duration rainfall events under 24 hours in many cases. You see on the upper right-hand corner some events that are of significance. In particular, if you remember 2023, we had about 26 inches in under 24 hours in Fort Lauderdale. I mean, think about that. That's like close to half the year's worth of rainfall. So intensification, particularly at sub-daily duration, could be significant. Globally and locally, we know that the intensification will happen with the warming, about 7% per degree Celsius, but it could be higher because the storm dynamics could also be significant. So South Florida, in general, in Florida, USGS Water Management District and Florida Flood Hub are working on understanding how this intense rainfall will happen in the future, what type of increases we are going to see. And the data to date shows about 10 to 20% increase. that report is pending, and that will be useful for us for future planning in stormwater management. So the idea is traditionally we have been using the design rainfall values that do not account for intensification, and that itself could be basically lead to under-designed drainage system and greater infrastructure damage. So that's also another factor. So sea level rise, I think we already talked about that a little bit. We have seen about 1 to 2 inches per sea level rise per decade, including about 6 inches at Key West since about 2000. We also have noticed that rapid increase since about 2012. And you see this up right-hand figure there. It's a heat map. Vertical axis is years and horizontal axis is the day of the year. You can see after about 2015, you see more red in there. That means more hours of sea level rise above mean high water in the most recent 10 to 15 years. We also have the unified sea level rise projection produced by the Climate Compact, and that is basically the regional planning standard for now until some new data becomes available. So these ranges help us guide the critical infrastructure planning from drainage to transportation to coastal structures. Another important aspect that we have to think about is the saltwater intrusion. Southeast Florida, which is driven by sea level rise and groundwater withdrawals, is progressively contaminating our coastal freshwater aquifers. You see on the left-hand side, upper left-hand side, many of you probably know that it's in the form of a wedge. So we worry about when that toe of that wedge is touching our freshwater well fields. Upper right-hand side, we see the potential for the saltwater intrusion, how they could affect the building foundations in coastal regions. That was produced by Professor Mike Sukup at FIU. So saltwater intrusion is a real concern that we need to think about how to continue the investment in wellfield protection and alternative water supply. Finally, some key takeaways. We see a remarkable consistency when you look at the global to national to regional. The trend is basically pointing the same direction: warming climate, rising seas, more intense rainfall, and growing risk, right? The second point there is the compact leadership is essential. By co-producing climate indicators, we ensure every jurisdiction has access to the same high-quality, science-based, actionable data. And finally, unfortunately, most indicators are trending in the wrong direction, right? Nighttime heat, sea level rise, saltwater intrusion, rainfall extremes. So this underscores the critical need for continued investment in adaptation and resilience, a main topic of this summit going forward. Thank you.